Okay, everyone, we're back live here on PALS TV. Next, one of our favorite segments every week, heading over to Professor Phil's lab. Obviously wears many different capes and hats around here at PALS. I love the chef in him, but I definitely appreciate the academic more. So we'll always learn different things with the virus and history lessons, and we're working on our reading skills and our book club sessions. But now we got our science class, so hopefully we have some more luck this week with our experiments. So Professor Phil.
Oh, what an awesome night is this. From the very first days when stinking bits of slime crawled from the sea and shouted to the stars, "I am man." Our greatest fear has been that of our own mortality. But tonight, we hurl the mighty gauntlet of science into the frightful face of death itself. We will ascend to the heavens. We will command the thunder and penetrate the impervious womb of nature herself. Actually, we're doing that next week, because next week is electricity, and that'll be a good time. Today, we are going to do food kitchen sort of things. Everything we do is stuff you probably have at home. There are a couple of things that not everybody has, but they're all things that you can get at the grocers. So that won't be any problem at all. And because it's the least messy of everything, and it takes forever, we're going to start with making our own bacteria and fungus colonies. We have no idea what's going to be in here. That is the entire point of this. We're going to set it up so that you can do this yourself. This is a long process. We won't see this finish until next week, but we got to start it now so we can see what we're doing. So the first thing we're going to need to do is get a home for our bacteria to live. And you will need as many of these as you want, different places you want to check where bacteria are. All you need is a regular plastic cup, and then you will cut the very end off. Just take some scissors and cut that off. So it ends up looking like this. You can put a piece of white bread in here, or you can make your own fake agar solution, or agar. I have no idea how to pronounce it. In proper biological labs, that's something that's made from red seaweed, and it serves as food for your bacteria. You can make the same thing, either just by using white bread, because that's all sugar and gluten, or you can take some stock, chicken, or beef. Don't use the vegetable stock. You want chicken or beef because you want the good proteins in there. Pour that into a saucepan. Add a little bit of sugar. For every cup of stock you use, about a tablespoon of sugar. And you'll boil that for a bit. And once that's come to a good boil, you throw a packet of gelatin in there. Just plain ordinary gelatin. I suppose you could use Jell-O powder, but that seems excessive and expensive. And then you'll get your own gel in there. That's what we're looking for. So then you'll want a full cup for every one of those you do. And that's just going to sit there and keep it safe afterward. So I have 4 places for my bacteria to live. So the question is, where are we going to find bacteria? Well, essentially, you're going to find bacteria everywhere. Oh, I left my gloves way on the other side. Now, we're not getting anything really messy, but we are going to mess with bacteria. So you're going to want to put on gloves at least for this. Well, there's nothing exploding. There's nothing flying up in the air. We should be fine for most things. All right, so the very first thing, I get that not everybody has hemostats at home, but I do. So that's what I'm going to use to pick this stuff up. I'm going to use a different pair for every bacteria that I use so that I don't cross the bacteria from different places. I want to see what's in a specific place. So if I was getting the bacteria from my cutting board and from the inside of my sink, I wouldn't want to cross those because I want to know how much is on the cutting board and how much is in the sink. Those should be separate. This one I've got here, I have already taken my sample. This is from my toilet at home. I figured that's a good place to find bacteria. They always say your toilet's dirty. So you take your sample and you take your growth medium, essentially your fake agar or your piece of bread, and just lightly, don't rub real hard, just lightly brush. Bacteria are right there. Just get a little bit on there. Put those bacteria all over there, and then you will put that away. That came from the toilet, so I'm definitely sealing and closing it and putting it far away. And I will take these hemostats and put them up as well, because they touch that. And I don't want to get things weird and cross-contaminated. So I have another cotton ball. What kind of bacteria is in me? So I'm going to take this one, and I'm going to get the inside of my mouth. You can also just use Q-tips, which are probably easier, but I don't own Q-tips because Q-tips are not safer. The reason I don't own Q-tips is because I would use them to clean my ears, and you should not do that. It is dangerous to put a Q-tip in your ear. It tells you on the package not to.
I'm sorry, this tangent was my fault.
It says it right on the package. Don't put these things in your ear. I had a friend in college, and she put one in her ear, and she punctured her eardrum. Bleeding all out the ear. It was horrible. So I'm just going to put this, and I'm going to wipe the inside of my cheek. I should get some good bacteria there. And then number 2. Just dab it on there, and we'll get all that bacteria. Igor, could you bring the trash and I'll just dump this straight in there?
Give me the
Yeah. Walk this way, master. Again, I'm going to take my clamp and I'm going to put that one up and use a different one for the next thing. And if you'll follow me, we're going to go grab a different thing. Actually, we're going to go that way. Twice, in fact. So, one of the places you find a lot of bacteria is just on door handles. You notice, particularly if you're in the vocational crews, we spend a lot of time disinfecting the door. So we're just going to wipe on the door handle, see what we can pick up. Fortunately, we've had a little bit of rain, so there's just a touch of moisture in there. And then we're going to take this one. Just put a little there. Igor. We'll throw that away. Put up the clamp till we get the next one. And again, we're going to do a bit of travel for this. We've already got my toilet at home. Let's see what the art studio's toilet has and see if mine's cleaner. Follow me.
Professor Phil's cruel.
So we could just get the seat, but that's no fun. We're going to get the inner rim. So we just lift this up. Another great reason to wear gloves. And just take a quick wipe. There we go. You'll notice I did not touch the door handle with my hands, even though I'm wearing gloves. I was just touching filthy things. I don't want to cover the door handles. And we'll just spread that on there. Make sure we got everything into our growth medium. Put up those clamps, and we can take off our gloves now. Then we will take these tops and slide them over. We don't want to forget what they are, so we'll take a Sharpie and just write on it. So fill toilet, that's our first one. And then my next one was fill mouth. If we had a dog here, we could test that thing, whether a dog's mouth is filthier than a person's mouth. But I don't have a dog here.
Oh, man.
And I have not done the requisite ethical groundwork to say if I can experiment with animals. So
Also, Phil doesn't brush his teeth.
I do brush my teeth. I've got one of those cool electric toothbrushes. And I usually keep at least 2 liters of mouthwash on hands at all times, because I like mouthwash. You can also use it to clean your floor if you've got Listerine. That was its original purpose, was as an antiseptic cleaner for hospital floors. And then we've got the door, and we've got the AOTL toilet. But this time I wrote bathroom, and that's very confusing. It's not that confusing. All right, so these we will look at again next week and see what we've got. We'll slide those to the side for now. Yeah, I think it's time. This could be a lot of fun if it goes wrong. If it goes right, it won't be that exciting. It will be amusing though. Igor, if you could take this spot.
I don't need to be like actually scared, right?
What?
Hey, everyone.
You know I don't test things. I have here a common, ordinary balloon that I blew up earlier. It's a nice dark purple color. In one of these hands, yeah, I have a lighter. Igor, what's going to happen if I set fire to this balloon over your head?
I hope it just goes away.
It'll just disappear?
Yeah.
You think it might pop and make a loud noise and scare the crap out of us?
Probably.
It's probably going to pop. If you set fire to a balloon that you've blown up, it'll pop and make a loud noise. Also, the material will fly all over the place at great speed. So we are definitely going to wear safety glasses for this. Igor?
Thanks, Professor.
It's Frankenstein.
Frankenstein?
All right, so let's go ahead and test this. I'm going to set this right over Bianca's head and set it on fire. And it goes really quickly. It doesn't take anything to burn through a water or a balloon.
Oh,
in
my
this balloon, this is all water. I've got a nice big water balloon here. What do you think's going to happen if you set fire to this one on top of your head?
Oh, am I going to get wet?
That is a distinct possibility. So let's find out.
Oh, God.
Where's the fire? We set it right there. Oh, it's still burning there. Oh, it's still going. We can go for a really long time because this is a lot of water. You can see that it's already marked the area with the black soot from the lighter, but it won't burn through the plastic. What is happening here is that all the water is taking up the heat. So none of the heat melts through the plastic of the balloon. This is such a good trick that you can make tea or coffee, but you shouldn't boil water for coffee. It makes it taste bad. But you can make tea in a paper bag over a fire. as long as your paper bag doesn't leak too much. All that water will absorb the heat, and it'll make that, and it'll keep the paper from burning over your campfire.
What if I just took this balloon and was like, Professor Phil?
Then you would get your computer wet, and people would be upset. All right, let me set that to the side here. As long as we're playing with fire, let's play with a little more fire. I have here an Erlenmeyer flask, and we're definitely going outside for this one because there's enough flame that I wouldn't want to set anything off. And I have a hard-boiled egg, which does not fit, but I want it inside there. And fire will help me do that. Igor. Yeah. Don't forget your tools. Fortunately, it has stopped raining.
Where do you want this?
Oh, just so we can see this.
Okay.
All right, so we've got our flask. There's some paper in there already. We've got our egg. And I've got this piece of paper here. I'm going to set this on fire and then shove it in there to get that, and then put the egg right on top. And then we play the waiting game. All right, I can feel it getting warmer. Oh, the waiting game sucks. I wonder if we've killed all the oxygen in there.
Patience. Can you guys see this? Please say thumbs up if you can see this.
Yeah, everybody can see.
All right.
And I can see it charring. I cannot see it continuing to go. Classically, we've done this once again. But as we said the other day in the Greek cooking class here at the studio, if science teaches us anything,
Add more garlic.
it teaches us to accept our failures as well as our successes with quiet dignity and grace. Stupid egg! What? Quiet dignity and grace. I'm going to leave this out here in case it relights and something horrible happens. We don't want that inside. All right, now we're getting to the fun, messy bit once again. So, if we're going to mess around with stuff, we need our lab coat. Again, always wear the lab coat just in case you spill something on yourself. Not only if it's messy, but if it's dangerous, then you can whip this off really easily and not get anything dangerous on your skin. Make sure you button the lab coat all the way up, or it just isn't doing its job. Put that one backwards. All right, so everybody loves the classic make a volcano and then put some baking soda in it and then put the vinegar in it and the volcano goes. I enjoy that one, but I think it's a lot more fun to make the volcano itself explode. It has been fairly humid with all the rain, so mine haven't dried as much as they wish, so they're upside down volcanoes because I can't get them out of my molds, but it'll still be good. This right here, it is not just baking soda, but you can make a mold of things. With baking soda, let's call this a cup of baking soda, and then half a cup of Epsom salts and half a cup of citric acid. If you combine these with a tiny little bit of water, mix them all in, and then put some scent into it, and color if you like, I'd recommend using soap dye. That's a bath bomb. So you can make your own bath bombs. That's exactly the recipe that I did, except I put moisturizer in my bath bombs. But they haven't dried out quite as much as I'd like with all the water. But a bath bomb is your exploding volcano. I've just added some green food coloring to my vinegar here because the orange and green I think would look pretty. So that's what we're gonna do. Ooh, a little bit of volcano already fell off. There we go. Well, we'll come up in a fun bubble and we'll continue because it will filter its way down through the body of our volcano. If it was upside down, we had a nice cone. It'd fall apart and into itself. That'd be really neat. So that one's kind of small. Let's see what happens with a slightly larger one. Oh, we'll start in the middle. There's lots of little holes in this one, so it should get in there pretty well. Get in there. Again, we've got tons of baking soda here, so everything, when it slows down, it is the loss of the acetic acid in the vinegar that we need more of that. And this is much less messy than when I do it over at PALS. I mean, there's a bit on the table, but the molds are working really well at keeping it together. Let's just pour the rest of it in. And that will just continue to go. Oh, this one's started up again and pouring all over the table. That's really nice. And these will continue to go the entire time. Yeah, I bet we can use that later. Okay. Pardon me. Can you hand me that supper, please?
Yes.
I'm a little parched. Don't drink stuff in your lab or eat things in your lab. You could poison yourself. It's dangerous. I just did a horrible, dumb thing. Don't ever do that. Danger, danger, danger. I was going to try this with the other egg that we used, but since it didn't go into the flask, you remember when I threw that egg on the ground? Did we get a picture of that? Did you go to the egg? Okay, so we saw that the hard-boiled egg, you throw it on the ground, and it falls into a bunch of different pieces. It just shatters and rips apart. I have another egg. But now I won't have lunch. I'm just going to set this into this beaker here. Igor, could you bring the vinegar, please?
Yes.
An egg on the inside is mostly protein and fat. It's just the stuff that the baby chicken needs to eat. Although there are no baby chickens in the ones you get here from the store. The outside, the shell itself, is calcium, which is a metal. It is the most common metal in your body itself, and it is the outside. Vinegar, as we've discussed, is acetic acid. So what happens if we cover this metal in acid? Well, let's find out. All right, so we're just over it. Nothing has happened yet. This is another one that's going to take a long time that we will see next week. Usually about 3 to 4 days. If you're going to do this at home and you've got a lot of food scraps around, you can use more than just hard-boiled eggs. Because you can eat a hard-boiled egg, but you can't eat chicken bones. So if you throw chicken bones, again, lots of calcium, into vinegar, acetic acid, you will have the same sort of thing happen that you will see next time, but not this time. Let me slide that aside. Oh, perfect. No particular reason for the bottom of the egg to turn green, although we definitely could just for fun. You want to dye an egg? Let's dye an egg. Just green vinegar. Let's pour that in there too. If only I had some ham to throw in there, and then we could see what happens to that, and we'd have green eggs and ham, and it'd be awesome. I believe that enough to set. Set those there. Move that there. Come over here. Steal this one. We're going to move down to this end for our next bit, and we're going to make a nice water rainbow. Actually, nah, we're not going to do that. I forgot that Caitlin wanted to make candy, so we're going to make some candy first. But we are going to be on that.
Am I following you?
I need to graduate cylinder for this. I enjoy sugar, so this one is about 5 tablespoons of sugar. You can go with, no, it's 6 because I did too many. It told me to do 5. I put some more in because that's the way I like it. And citric acid, same thing we were using in our bath bombs. And we're going to take 6 teaspoons of this and throw it in there. 1 teaspoon is, or 3 teaspoons is 1 tablespoon. So 6 teaspoons, 2 of these big tablespoons. Dump that in there, you can hardly tell the difference. Looks almost the same. Dump that one in there. Okay. Close your bag, you don't want stuff getting in your food grade anything. Ooh, it's all natural. And our good friend baking soda, which in your house probably comes in a box instead of in a home canister, but I buy it by the 5-gallon bucket, so I carry it around in this so I can actually use it. This 5-gallon bucket of baking soda is really heavy. And we're going to get 3 tablespoons of this. Make sure it's not too clumpy. Warm nice and flat. When you buy measuring spoons and measuring cups, get ones that are straight across the top, and then you can just slide over. You know it's exactly the right volume. And then get a different recipe. Never cook by volume, cook by weight. Then we'll get 2. And 3. That is slightly too small to actually stir up.
Did you get anything?
You got a quick bowl right around?
I can get a mug.
Yeah, mug of wood. If it's just going to be you eating this, you can go ahead and stir it with your finger. I'm going to use a probe here. So it's not just me. Hey, mug. See if we can get it all in there without spilling too terribly much. Make sure you get any chunks. Both citric acid and baking soda tend to clump fairly easily with water. So what happens when we put water and baking soda together? We get that kind of fizzy thing. If we've got an acid, like vinegar, we get very fizzy. This one's quite clumpy. So we want lots of fizz. Vinegar is not the only acid out there that is easy to get a hold of. You yourself produce quite a bit of different types of acids. One of the acids that you produce is saliva. I have a candy cane here. Not really a cane. I've got a candy stick in the peppermint variety. Allow me to open this. If it's just you, you can just use your finger to do this. It's not just me. So I'm going to open this thing up without putting my hands all over it. And just pull it back a bit. We don't need the entire thing exposed. Igor?
Yes?
Yeah, you better separate that.
Separate what?
When you're doing this, if you got more than one person, separate that. Wet that.
With my mouth?
Yeah.
Oh my God.
I'll get you a little more of this. It's classic dessert. Shove her in there.
Shove it in there?
Yeah.
With my, okay.
Yeah.
Like this?
Yeah, roll it around. Get a bunch of it. Get it in there. Get it on there. All right, so peppermint, nice and refreshing. Oh, what happens if we put baking soda on it? And sugar and citric acid. A lot of sugar. Instead of sugar, if you have a pre-sweetened like Kool-Aid mix or something, you can use that instead. That's more color. Good? Give her a taste. Shove it in your mouth. See what happens.
Oh, it's sour.
Is it sparkly?
Yeah.
like tiny pop rocks.
Yes.
These are essentially how you make pop rocks. It's just a baking soda reaction. You can keep doing this.
You wanna try some?
No. This is why we got two. You don't want to swap spit. You can give somebody COVID. I've been wearing the gloves, so my hands are clean. Oh, that's a lot of citric acid. Woo!
It feels crazy.
Oh, that is sparkly.
Ooh.
Even though I overdid the sugar, I would up that sugar. Go with maybe a cup of sugar, 2 tablespoons of the citric acid, and 3 of the baking soda. That'll give you plenty. Oh, nothing else should be exploding at this time, so I'm going to go ahead and remove my goggles. Oh, cool. Okay. Let me get rid of some of this. Don't need all of that. Okay. Oh,
I know.
could you bring the large thing? I'm not making tea. I'm making science. Oh, it's still nice and warm. Okay, I've got a cup here. I want to make sure I get all the things. I'm going to go with about 10 milliliters of water. Also, millimeters of that is way too much. Well, that's really hot. You don't need to be precise on this one at all. All right, 10 milliliters of water, and although I accidentally said millimeters, it's the same thing if you talk about cubic millimeters. That's why the international standard is really handy for measurement. Igor, could I have food coloring and sugar, please? Throw the first switch. Regular old sugar, you can use pretty much any crystalline thing that dissolves into water. Salt, citric acid. I wouldn't use baking soda. We're going to put a couple drops of the red food coloring in here. Just a couple. We are going to put, let's go with our smallest. I've got an 8. No, let's go ahead and go big. That's not the big one. We're going to put a full tablespoon into 10 milliliters of water. That is a ridiculous amount. It should not go in there. There's more sugar. That's exaggerated. Should have used more water. Quarter. Okay. Let's go with teaspoons instead. A teaspoon. Put a full teaspoon in there. That is way too much. If you were just putting a teaspoon of sugar into 10 milliliters of water, it would not get in there. However, popped it up and boiled it in my handy dandy kettle, so this is quite warm. You can get a lot more solid into a liquid if you heat it up. I'm going to try another teaspoon. Until I can see the sugar just sitting in here, I'm going to keep adding. So 2 teaspoons. Keep track, keep track. Understood? You want to add one more? Yeah, I could have got a tablespoon in there because, as you know, 3 teaspoons, 1 tablespoon. All right, I think that's all we're going to get in. There you go. Could you grab me a spoon? Any spoon, doesn't matter. I'm going to pour this in. It's quite thick and syrupy at this point. It's like candy medicine. There's already a fair bit of red in there, so I'm just going to add a drop or 2 of yellow. Red and yellow we're going to get. Igor?
You guys see me?
Yeah. Yes. Art director.
Orange!
Hey! We're going to go with 2 tablespoons. Since I know where the water came up to on this one, I know what 10 milliliters is. So I'm just going to pour directly into here for that much. And we stir until it completely dissolves. Spoon. If we pour over the top of the spoon, it'll slow down the drop of the water and it won't mix up as it normally would.
Should we get closer?
No, I dropped it there. I think I'm going too fast. Oh, that's not working. Let's do it the other way. Going blue now. Quite blue. I'm just going to put an 1/8 teaspoon of sugar in this one. Let's go with 1/4. So 2/8. And 10 milliliters of water. Touch more. Give her a stir until all that dissolves. Ever pour black and tan?
No.
No. This is the same way you pour a drink called black and tan.
Oh yeah, I poured a blackened. I thought you said blackened can.
No, a black and tan. You any
Yeah,
good
like
at
the,
it?
like the beer. Yeah.
Because I'm clearly not. Go let the professional handle it.
I'm not a professional. You want me to hit the spoon?
Yes, that slows down. I thought you said you've done this.
Oh,
Oh, there we go. Yeah, we're
Okay.
good.
I've done it. See? How much do you want?
I need the whole thing. A little slower.
It's like so, takes so long. Okay.
And we're gonna get one more with green and no sugar at all. Oh, that was way too much. But, I mean, it doesn't matter. All right, so you can see, we're just pouring sugar water into itself. But we've got this nice separation between the red and the blue, and I can see a separation in the green. I doubt you can. I put those together too dark. I didn't think that one through.
I was gonna say something, but I didn't know if it was my face.
Yes, yes, person who knows color.
I didn't want to overstep Professor Phil.
Yeah, that color gradation is not coming through for you. I can just barely see it here live. But you can see, we gotta get close for this one. The red at the bottom is clearly separated from the blue and the green up here. This is just because of density. There's a lot of stuff in the water at the bottom, and this stuff is light. However, it's all the same stuff. So if I give it a good shake.
Oh. It doesn't move?
Well, if I could do it without spilling it all over myself. There's less red there. It has started to mix. Hey, let's pour it into here. So it mixes all together. There's no separation because it's all the same stuff, and all that sugar that was in the bottom one goes through all the top. And we'll see you guys next week. Ta-ra!
Oh, that was good. Yay, Professor Phil!
Blue and green. That was an interesting choice there, Professor Phil.
I didn't think that one through first.
And I know a few that can probably help you out. All your other experiments were great. You had a wonderful helper there, so we appreciate Igor stepping in and
Wow, thanks.
helping out. You did a great job. So thank you. We always love our time over in Professor Phil's lab. So join him again here next week on PALS TV. All right, everyone. Well, we're getting ready for our lunch hour here on PALS TV. So next will be live from Heath, Ohio. and we'll be joining Gary. So come back and join us here in 15 minutes. See everyone soon.